Welcome to Biology My Passion. I am Soumya Harikrishna. In this channel, we are studying science of classes 9 and 10 and biology NEET level for classes 11 and 12. We have completed all the biology chapters and first chapter of chemistry in class 9. A few MCQs also have been released. Soon I will be releasing the important questions of the first chapter of chemistry. We started with the second chapter, is matter around us pure, and we learn up to suspensions and colloids. That is, solution, suspension and colloid we discussed. They are mixtures. Solution is homogeneous mixture, whereas the suspension and colloids are heterogeneous mixture. So mixture means different types of substances are there present. But matter can be in pure form also. So pure substances means what? Only one type of substances will be present in that. So today we are going to learn about pure substances. So many times we just mentioned that the heterogeneous mixture can be physically separated into its components, whereas homogeneous mixture it is not possible. All these. So we should basically understand what is the difference between physical changes and chemical changes. So physical changes means only some state of matter is changing or some rearrangement is happening in that. But chemical change means some components are combining and it forms a totally new substance and it is an irreversible change. Whereas physical change is a reversible change. When we talked about the change of substances, changes of matter, that is from solid to liquid, when we are heating the ice it becomes liquid form, and when we boil the liquid we get the vapor form. So here all only interconversion of the states happen, which is just a physical change. But if you see it in the solid form, that is ice, or in the liquid form, that is water, or the gaseous form, that is water vapor, the composition remains the same. That is, two atoms of hydrogen combines with one atom of oxygen, the ratio 1:8. Okay, so the composition doesn't change, so it is only a physical process, and also we can reverse this process. Let's take two examples. One water, the other one cooking oil. We know that water and cooking oil both are liquids. But do they have the same composition? No. Water has a composition which is different from liquid. So their properties also vary. We know water has no special odor or color of its own. And when it comes to cooking oil, we know that each cooking oil has got its own typical odor or it has its own properties also. And another wonderful observation is, if you have to put off fire or extinguish fire, we can put water over that so that the fire will get extinguished. But at the same time, if you heat cooking oil, it may catch fire also. So these are two different properties. Why this is happening? Because of their different chemical compositions. Burning, if you say, it is a chemical change. Why it is a chemical change? It is making a lot of changes to the chemical properties of the substances involved, and finally we get a new substance which is different in properties than the component substances. So here are a few examples given in your textbook. That is, first is a cutting of tree. Cutting of tree is a physical process. Or if you think about burning a piece of butter in pan. You know that when you are burning a butter in pan, it is just melting from solid to liquid. But if you cool down again, it is going to be solidified. And also we are not going to get a new substance with a different property. So it is also a physical process. Next is a rusting of an iron almirah. It is a chemical process because here iron is changing into a hydrated form of its compound called a rust. So that is a new substance forming with a different property. So it is a chemical change. But if you boil water to make it into water vapor, it is again a physical process because there is no new substance with a new property is forming. Now if you pass some electricity through water, you know that water can be split into hydrogen and oxygen, its components. So it is a chemical process because we are getting two different substances out of it. But if you add some salt into water and make a salt solution, you are not going to get a new substance. You will get salt within that water as a mixture only. And also, if you are making raw fruits and mix them to form a fruit salad, it's just a mixture. We are not making any new substance. So it is also a physical change. Now let's talk about the types of pure substances. Pure substances can be of two types, elements and compounds. I told they are made up of only one type of substances. So elements basically made up of identical form of atoms, whereas compounds are formed of different molecules, we can say. Now, when we talk about elements, the word element was first coined by a scientist called Robert Boyle in the year 1661. And Anthony Lavoisier, the scientist, defined or gave the proper definition of elements. So according to him, element is a basic form of matter which cannot be broken down into simple substances further. If I say hydrogen is an element, hydrogen has its own atom with that property. I cannot further divide it into again further substances. Okay. So, these elements are having different properties. More than 100 elements are known to us now, and of them 92 are naturally occurring, rest are man-made. Majority of the elements occur in solid state, 11 of them occur in gaseous state, 2 of them occur at as liquid at room temperature, for example mercury and bromine, and gallium and cesium are two metals which if you keep in your palm, they may melt because their melting point is little higher than the room temperature, that is 303 Kelvin. Now you know how to convert Kelvin to Celsius, minus 273, 30 degrees Celsius it will melt. So in the palm the temperature is high because our body temperature average is 37 degree average. So it will melt. Elements can be further classified into metals, non-metals and metalloids. They are arranged in the periodic table. So metals are found at the left side of the periodic table. Here you can see majority of them are metals, and the right side is occupied by non-metals. But when it comes to in between, there are a few elements which have the properties of both metals as well as non-metals. They are called metalloids. So if you see the properties of metals, metals are lustrous, means any metal you see, they have a shiny surface. They basically have yellowish or grey silver color they have, and they are having a property called a ductility. That means they can be drawn into thin wires. So if you see gold we use for making different ornaments with the different fashions. How is it possible? Because we can draw them into thin wires and then make the different designs. The same way, if you look at their other property called a malleability, they can be beaten into thin sheets very easily. That property is called a malleability. Especially if you see the aluminium foil and all that we are using, it's a thin sheet of aluminium metal, right? So that is called a malleability. And when you come to the conductivity, the metals can conduct heat and electricity. But if you say which is the best conductor, silver is the best conductor. Okay, and there is a poor conductor, lead. Though it is a metal, it is a poor conductor of electricity. Another property of metals is they are sonorous, because if you beat them, they will make a ringing sound. Or if a metal falls from my hand, it will have a ringing sound, whereas if it is a paper or a book or a box, it is plastic thing falling, it makes a different sound. So that ringing sound is called a sonorous. The property of metal is called a sonorous. Usually metals are solid. Examples of metals, what are the examples you are familiar with? Gold, silver, copper, iron. All these are metals, but there is one metal which is liquid at room temperature, that is mercury. Mercury is represented by Hg. About the symbols we will learn in the coming chapters. So mercury is a metal which is liquid at a room temperature. These exceptions you have to remember. So now we come to properties of non-metals. They don't have the properties of metals. That means they are not ductile, they are not malleable, they are not sonorous, they cannot conduct heat and electricity, and many of them are in the gaseous form or in the solid form. And the non-metal which is liquid at room temperature is bromine. Usually they are not lustrous. There also one exception is there. Iodine is a non-metal which is lustrous. So examples of non-metals, if you see hydrogen, oxygen, carbon, nitrogen, then you can say about bromine, iodine, all these are non-metals. Now comes a few elements which are neither metals nor non-metals, or they have the properties of both. So they are coming in between these two. Example, boron, silicon, germanium, etc. Now we have to talk about the second type of pure substance, that is compound. So compounds are consisting of two or more elements in them, but in a definite proportion. For example, if I see water, water is a compound. It has got two elements in it, hydrogen and oxygen. If you see by mass, hydrogen and oxygen are in the ratio 1:8. Their mass proportion should be fixed. If you change this, you will not get water. So any form, if you check the chemical composition, or they are made in a fixed proportion by mass. And can we break them down? Yes. We couldn't break down elements further, but here it can be broken down into its component elements by some chemical processes. Now we will have a doubt about then what is the difference between mixture, because mixture is also, we are mixing different pure substances and we are getting mixture. Here also compound is a mixture of different substances. But what is the main difference here? Suppose if I add this one, the soil or salt, copper sulfate crystal, just mix them physically, I am not going to get a new substance out of it with a different property, but each one will show their own properties. Whereas if I make a compound using two different elements, I am going to get a new substance like water, which does not have the property of hydrogen or oxygen individually, but it has its own new properties. So it's a new substance that we are getting, not still a mixture. Now the composition may vary in a mixture. Suppose I am taking 1 glass of water, I am adding 1 spoon of sugar and giving you. But another person wants 2 spoons of sugar, or I can add 3 spoons. So any composition I can add, or I can take 1 spoon of copper sulfate, mix it with 2 spoons of potassium permanganate. It's possible. Or I can mix 2 tablespoons of sugar with 3 tablespoons of salt, or later I can mix it in a different proportion also. But in compounds, there is a definite proportion I told by mass. It should be in 1:8 if it is in the case of water. In mixture, the property is the property of the component substances. Suppose if I mix a salt and sugar and I taste it, it will have the property of salt, it will have the taste of sugar also. But the compound is not like that. Now it does not have the property of hydrogen or oxygen, it has only the property of the water. The same way, sodium is an element, it has its own property, it's a metal, whereas chlorine is a non-metal. But if they both combine together, we get a new substance called the sodium chloride. That is nothing but our salt, common salt. But if I taste a salt, it is not having property of a sodium, or it is not having the property of chlorine. It's a new substance with its own property and its own taste, color, everything. Now, if it is a mixture, we can separate their components by physical methods. Okay, either by filtering or evaporation, like that we can separate them out back. But if it is already made into a compound, by physical means we cannot split them back or get them back. Only we have to go for chemical reactions or electrochemical reactions. Hope you understood all the concepts that we discussed today very well. If you like my videos, please don't forget to press that like button. Also share with your friends if you find this is valuable, and also if you have not subscribed to my channel, please do so. Thank you for watching Biology My Passion.